Welcome.
Welcome to propellers. Okay, propellers. I think that I went way overboard on my notes for propellers, and I probably made things way more redundant, complicated than I needed to, so I'm going to have to cut a few things out, maybe get us a little back on track, and give you the information you need without, like, that was a bit much. But I love to start out this whole props thing with a wonderful quote by Orville Wright. Some of you may have heard of him. He invented popcorn.
Oh, yeah.
But he seemed to know a little bit about props. All right, so propellers. So we're talking about props, which is basically a wing that goes around in circles. And you've already had helicopters with fill. So how hard could it be?
Pretty hard.
It's like a helicopter blade turned vertical. It doesn't have half the stuff on it, so it must be easy. But Orville says this: it was apparent that a propeller was simply an aeroplane traveling in a spiral course. As we could calculate the effects of an airplane traveling in a straight course, why should we not be able to calculate the effect of one traveling in a spiral course? Right? At first glance, this does not appear difficult, but on further consideration, it is hard to even find a point from which to make a start.
Oh, geez.
The thrust depends upon the speed and the angle at which the blade strikes the air. Speed and angle. The angle at which the blade strikes the air depends upon the speed at which the propeller is turning. The speed the machine is traveling forward and the speed at which the air is slipping backwards. They all come into play. When any one of these changes, it changes all the rest, as they are all interdependent upon one another.
Wow.
Yeah. So in other words, if you think about it, what he's saying is we have a propeller, and if it's going like this, why, that's just a wing going in a circle.
Yeah.
And you could vary the angle of that blade, and you would say, well, that would be, you want about a 4-degree angle. So that's 4 degrees, and the air is coming this way, and that would make perfect sense, wouldn't it?
Mm-hmm.
Okay, but then if I take one step forward while I'm doing that, I just changed that wind coming from this way to this way.
Mm-hmm.
And that changed the entire angle. So the plane sitting still has one angle. The plane moving forward at 10 miles an hour has this angle. 100 miles an hour has this angle. So the wind is constantly doing this to the wing that's going around like this. And if you change the RPM or the forward speed of the aircraft, you change everything.
Yeah.
And then once you realize that, you suddenly realize why constant speed propellers are so much better. Because if you have a fixed pitch propeller, it's really only designed for one forward speed at 1 RPM. And the airplane is not designed for one forward speed at 1 RPM. Because we already talked about what you have when you have a fixed pitch propeller and you're at 1,000 feet, where's 65 or 70% horsepower versus where's 75% power at 10,000 feet. It's wide open. So up here, your RPM is much higher to get the horsepower, and RPM down here. So you got to find one spot that works for everything, and it just doesn't work. So propellers tend to be problematic in that way, and we're going to kind of look at that. And it's good to have that understanding, because you have to understand what the engine is doing and why it's doing it. Right? So for example, I finished an annual on an airplane, and the customer goes out to get in the airplane and a little nervous because it just, had an annual inspection done. So they notice things they never noticed before, and he gets in and running it up, and you can hear do a full power run up, and taxi back, come back to the shop, turn it off. Never a good sign. And he gets out and says, hey, I got a problem. This thing is not reaching red line. Yeah, it never has and never will. Right? Well, but it gets a lot closer when I wear it on the runway. It should. Now you have to be able to explain that to a customer. Why did they not get red line, and why will they never will? And it never did. And you should know a little bit about that from engines, right? Because static RPM is given in the type certificate data sheet for the airplane, and it should be between two numbers that are a long way from the red line. Like if red line is 2750, it should be somewhere like 21 to 22 or somewhere around that neighborhood. Why? Because the propeller is designed to go forward, and now it's slapping the air at a very high angle of attack. It's a a shovel going. So the engine works as hard as it can, but man, it can't do it. Can't get red line. Then what happens when you take your feet off the brake, start rolling down? Well, the wind starts coming back around, and now you suddenly start to get that 4-degree angle. The prop is getting more and more efficient. You accelerate more, and the airplane starts accelerating, and now the prop's being used where it was designed, and it gets up closer to red line. But not quite, because you don't want to design it that way, right?
Yeah.
So that's just a very simple thing. But if you don't know that, I didn't know that, I would have been like, oh dang, yeah, you're right. Well, let me give you a ride home while I spend the next 4 weeks changing parts on your engine, never solving the problem. Hey man, I don't know what to tell you. I guess you need a new engine and a new prop, because it just don't work. I mean, we've changed the mags, changed the carb. We changed. What else did you change? Changed the cylinders. We
Painted a new red line.
yeah, we just finally yeah. So after spending weeks and weeks and all this money, we've just determined that you must need a new engine. So we got a new engine. Well, that didn't work. Maybe the prop is bad. We get a new prop. Well, that didn't work. It's all right where we started. I guess it was good all along. Well, see what happens when you don't know these things, right? So you got to know these things. All right, so we're going to talk about our fixed pitch propellers first. One most wonderful thing about fixed pitch props is the way they named things wrong. And by things wrong, they named the face and the back wrong. So if we are sitting in an airplane and we're looking out the front window, we would not see the prop looking like that. We would see it the other way around. But since I guess I have that picture, we can look at it. We are looking at the back of the propeller.
Oh.
So as a mechanic standing in front of the airplane, looking at the airplane, you're now looking at the back of the propeller. The pilot is sitting in the seat, getting ready to go flying. They're happy. They're looking at the face of the propeller. So the face of the prop faces the pilot. But what about if it's a pusher?
Oh no.
It's the same thing. You can turn around, the face faces the face. So no, wait a minute. It's gonna be a little. No, you're completely backwards. We have a pusher prop. Well, if you actually go look at the Skymaster, at first it just kind of because the flat side is still it's just wrong. The hub's on the wrong side. You follow? So yeah. So the pilot would have to get out and walk back like this, and then get behind the airplane without moving, and go, okay, it's still.
So the
face is still, huh?
The face position should just be from the drive-in, view from the drive-in.
No, I'm not going to say that because that wouldn't work for a pusher. The face is the part that faces the propeller when it's in the front, and the pilot's looking front. Or if it's a pusher prop, the face is what you would see if you went all the way back behind the airplane and stood behind the airplane and looked at both props. You'd be looking at both faces. But if you're in the middle, the pilot's looking at the face here, he turns around, he's going to see the back of that one. Maybe we're ready to just stick with this. This part right here is called the back, and the other side is called the face. Okay. Let's see, we want to go here, add new section, there we go, okay. View, got some lines. We'll just edit this out so it'll look really professional. All right. Fixed pitch props, all right. All right, so we got some, props, here we go. Props, let's talk about some nomenclature. Nomenclature. Things you need to know. Well, we've got the blade. And I'm not going to define them. Isn't that nice of me? Well, the blade is the thing that you would think is called a blade. I have a blade in here. I'm going to bring one in.
Gotta be sharp.
What's that?
No.
So obviously, this is the blade right here. Blade. There's blade. How many blades are on that prop?
2.
All right, 2 blades. I got the blade. We got the neck. We got the hub. All right. That's the hub on a fixed pitch because it says hub. And you don't have to take a picture of this because I think I stole it right out of your book. But some of you didn't know that. What did I say? The neck is this area right here. One of the things about metal props, they're a little more efficient because the neck can be shaped differently than on this. So that gives it more efficiency down near the hub. We talk about constant speeds, and we're going to talk about they're different pieces, right? You take a blade out. The hub is separate, so it's like a three-piece deal. We got the blade, neck, we got the hub bore. Hub bore. So that's the bore right in the middle. That goes on the pilot shaft coming off the crankshaft. If you look inside the hub bore on wooden props, it is aluminized paint. So it should look silver, almost like a metal sleeve has been pressed in there, but it's just paint. The hub bore, well, you got the bolt holes, you know what those are for. Where the bolts go. All right, got the blade tip. Blade tip. So blade tip is out there. All modern propellers, metal props. I don't know why they didn't do. I know why. All of the metal props are usually they're black or gray, and the tips are white. Fabric covered ones tend to look like this, where it's got some sort of olive drab fabric on it and a brass kind of tipping. Do you know why these are painted white?
The black will slide off, and the white is painted to hold it.
No. I think you're an idiot.
That's pretty funny.
Huh?
The ones that are
No, that was my story. So you remember the Model T? Henry Ford. No, you don't remember. I was
drove
there.
one.
any color you want.
Heard
You can have it any color you want as long as it's
Black.
black. Do you know why it had to be black?
Because that's the one that's
It's the best color.
Because I believe that any other color took way too long to dry. Black actually had a much higher drying rate, so it took the other colors a long time to dry. The problem with black is it has a very low adhesion to metal. So it worked fine until they started putting it on metal props. So the metal prop, it didn't stick so well, so the paint would actually slide off.
Shut up.
Yeah.
Really?
So what they did is they painted. See, thought he was joking. So they painted the tip a high visibility. It's a white color, or you sometimes you see them orange. But these lighter colors, although they didn't dry for a very long time, they had a much better adhesion. So because of that, without it, the black would actually slide off because of the centrifugal force. And I kid you not, in mechanics, what you'd have to do is you have to come out here, you have to cut off some of the paint that was sliding off, and you'd have to repaint the hubs because it would slide off, the hub would be bare, and then it would get corrosion.
There's no way.
So they painted it this lighter color, and it holds the paint from going off.
Tyler was like, wait, am I wrong?
No.
I was like, dude, I watched these videos like 7 months ago. I know the answer.
I just, where do you think you got the answer? You think I'm making it up?
I'm confusing everything. Yeah, I'm very lost right now.
So the paint doesn't slide off.
I don't think paint slides. Like,
Well, it doesn't
unless it's
anymore.
wet.
Well, now it sticks. We have Allodyne, we have primers, and the paint. Of course, you're not going to see that anymore, but it just became a thing.
Just
And then they
heats
said,
up.
hey, by the way, you can see it a little bit better. Now, you're going to buy it? Okay, I'm just making that up. This right here indicates how much of the tip you're allowed to saw off without a 337.
That makes more sense.
It does. That's still bullshit.
Just gotta write it. Saw off.
This is the best day ever.
Both of these are up there now. It's like,
Make sure you only do one side.
bro, in the oral, I'm saying it.
Yes, and and now if you know anything about props and you look at the face, which is the other side, you don't have the white stripe. All right, so what's the white stripe there for?
to keep the black paint on.
So you don't walk into the damn prop. It's there. It's a high visibility color, so you can see it.
That makes a lot of sense.
Why don't they put it on the other
So
side?
black.
Well, they can't. So I had a customer one time with a crop dusting service. He ran through a barbed wire fence, called me up, said, hey man, on your way home, could you stop by the airport and bring all of your files with you? And it was one of those like Ron Swanson things. Wait a minute. I believe what you heard is bring some files. What I said was, bring all of your files with you. And I got there, and the prop was a mess. And it was like, hey, can you file these things out? And here's some black paint. And he taught me this. He said, you know, he made it home, and he's like, I'm really concerned about this. I would be too. And he said, this happened to me before, and scraped a bunch of paint off, and I got flicker vertigo real bad and almost crashed. I'm like, yeah, what now? He's like, you don't know what flicker vertigo is? I'm like, no. So he gave me a little lesson. He was a cool dude. He's like, hey, back when movies first came out, now you're not going to believe anything I say. So this is actually, this is true. And the guy's name was Koppel Flying Service. He's long gone. But anyway, he told me the story. So I got a name to it. So you know it's true. Details. Now you know it's true. And so he said that back in the day when they first came out with movies, because you know movies actually flicker.
Mhm.
They didn't have the flickering right. And people would often get motion sick watching movies. He said that's flicker vertigo. And he said he got it real bad by a prop that was flashing in front of him. So that's a real thing. So the face of the prop is always painted a flat black. And it's really important that it stays flat black. The airport I work off of has a lot of loose gravel, and it really gets the tips, the face, not what you're seeing here, but the other side.
Yeah.
Really, the paint starts to come off the tips real easy, and so it's just standard practice I do on my prop. Usually every oil change, I have a little touch-up paint, just a little touch-up paint, so I don't get the flicker vertigo, because it makes you throw up. All right, we have the blade tip. It's painted a different color because
Vertigo.
no, so the paint doesn't slide off.
Hell no, man. We talk more about that in the actual cause. So,
So you don't walk.
In trouble
So
on
you
some
don't
things.
walk into the propeller.
Oh,
All right, we got the leading edge on aluminum propellers. The leading edge is just part of the aluminum, and you file it down until it isn't no good anymore. On modern propellers that are, your composite propellers, they're called composite. No, let me back up one. So start with the old ones. The wood propellers. Wood propellers have a brass edge that goes around them to protect it from rocks, chips, rain. Rain is hard on props. So they have a brass tipping. We'll talk more about that. And this is a fabric. Well, it says fabric. So it's fabric that's put on there. Watch a cute little video if you haven't already seen that. On the aluminum propellers, there's nothing there. It's just aluminum. They do make a product that you can, like a protective edge. I've never put it on. But now on the new, like the new prop, there's only a couple prop manufacturers. This is a Sense-Niche. That's a Macaulay. There's a Hartzell. And MT is like, those are the big ones these days, and that's all of them, the big ones. So MT props, they are the newest comer. They're the latest and the greatest composite prop. By composite, I mean they are wood with carbon fiber or fiberglass covering. So everything old is new again. All right. See, leading edge. And of course, we also have, just like everything else on a wing, A, B, C, F, G, H, we're going to have the trailing edge. And since you had Phil with aerodynamics, you are already educated in that. Let me see. So now I've got these other nomenclatures here, nomenclature. Now I've got back of blade. Well, I already got blade. Oh, I guess not. A, B, C, H. We talked about that. H. I. What is the back of blade? Back of blade. Curved or cambered. I like curved better. Everybody knows curved is. Curved side. And then the face of blade. Face of blade. That is the flat or side that faces pilot. We have a blade cord. Blade cord. What do you think that is?
From the leading edge.
What was it? Yeah. What was the definition for the wing cord?
Leading edge.
inches of trailing edge.
It doesn't start out with the imaginary line connected to, why do they say imaginary? It's an actual line. So
Yeah.
it is a line between the leading edge, LE, and trailing edge, TE. You guys haven't had weight and balance yet, have you?
No.
Okay. You have your Lee Mac and your T Mac. It's all leading edge and trailing edge stuff. Blade cord, we got that. And last but not least, HABKL, the blade station. Blade station. That is a distance in inches. That's got to be changing soon. We have too many things that are becoming metric. From center of hub. From center of hub. Now I guarantee you right here, somebody's going to miss a bunch of test questions because you forget about blade station. So blade station is the distance in inches from the center of the hub. So if I said I had a 72-inch prop, and what is the 50% station? So that'd be the 50% blade station in inches. First thing you have to do is a 72-inch prop is that big. And if I want to count from the hub out, I have to divide by 2. So it's a 3-foot prop, and halfway out would be 1.5 feet, or what, 15 inches. So, all right. Is that it for tonight? Almost. We'll leave right here. We'll talk about theory tomorrow. Theory.
Tomorrow or Wednesday?
Oh, I don't know. Probably tomorrow. We got to get back on track.
I think that's what we talked about.
Yeah.
So there's no test tomorrow?
There's test tomorrow.
There is, but I have to test because